Assalamu alaikum students. Many students were asking about the solution of the questions that were related to the identification of cations and anions, and they were demanding that the lessons are totally different from the questions that are coming in the examination or in the papers, just like we have encountered with the different type of questions in P4 alternative to practical that are coming in the form of the table, or some are in the type of separate form of the test. So this video is related to the solution of those questions in which the students are facing problem, and I am making this video to resolve your concerns and your misconceptions. So I am starting with the first question, that is from P4, and you have to utilize all those concepts, means that all those identification tests of cations and anions over here in order to solve this question. For example, the first lines are: L is a compound which contains two ions. Complete the table by adding the observations in tests A, B and C and both the test and observations for test D. So L is a compound that dissolves in water, and resulting solution is divided into three parts for tests B, C and D. First of all, we are dissolving L compound in water to forming an aqueous solution. When we are forming this solution, our conclusion means that we have got after this observation. So our conclusion is L is not a compound of transition metal. Means L is not a compound of transition metal. What is meant by this? Like it is not a compound of transition metal. We have already learned about the three specific properties of transition metals in periodic table, and those properties were characteristic properties of transition metals. These properties are not bared by all the metals, they are just only means that shown by only transition metals. The first property is this, like these means transition metals are used as catalyst in different chemical processes. They are used as a catalyst. Second one, transition metals form compounds with variable oxidation state. Variable oxidation state means, for example, if we are considering over here the one compound of iron is FeCl2 and other compound of iron is FeCl3. In this compound, iron bears the charge or valency 2 positive, but over here the iron has the oxidation number or oxidation state is 3 positive. So over here the charge on iron is 2 positive, but the charge on iron is 3 positive. It means they have the variable oxidation state. The third one is transition metals metals form colored compounds. Colored compounds. So these are the only metals that form the colored compounds, means their solids have different colors. Like if talking about the potassium dichromate, so it has orange color. Potassium dichromate has orange color, and that is because of the presence of this transition metal. This property is representing the first part, means that L is not a compound of transition metal. If it is not a compound of transition metal, it means that a colorless solution is produced. A colorless solution is produced. That's why we are ready to write that L is not a compound of transition metal. Now, for the second part, B part. When we were learning about the identification of cations, over there the two reagents were used to test or to identify for all the cations, and those were aqueous sodium hydroxide and aqueous ammonia. So for each compound, each ion has different identification. So over here to the first part, aqueous sodium hydroxide is added until change is seen, and in conclusion we have three ions: aluminium, zinc and calcium ions. So what type of precipitate these three cations will produce? What did you say? White. Oh, okay. So white precipitates will produce or will form. White precipitate will produce when we are adding an excess of aqueous sodium hydroxide is added to the mixture 1. So in our conclusion, aluminium and zinc ions are present. If aluminium and zinc ions are present, it means precipitates dissolve to produce clear solution. But if only calcium ion will be written over here, like calcium ion is present. If calcium ion is present, then this observation will be totally changed. Instead of writing precipitate dissolved to produce clear solution, then we will write that precipitate are not soluble, precipitates are insoluble. So these two statements we can write over here instead of writing precipitate dissolved to produce clear solution, and that only satisfy the calcium ion. But the calcium ion is depleted from here, so our observation will be precipitates dissolved to produce clear solution. Now for the second part, we are using aqueous ammonia. So for aqueous ammonia, aluminium and zinc at the start, they will produce white precipitate. That would be our observation, like white precipitates will produce Now in our last observation, we have found that aluminium ion is present. If we are recalling the concept or test of cation, aluminium cation, over there we had learned that for aluminium ion, the white precipitate that will produce in aqueous ammonia, they are insoluble in excess of aqueous ammonia. If you can recall or that flashback in your mind, so or if you had already memorized those tests, so you can easily identify that for aluminium ion these white precipitates are insoluble. White precipitates are simple, you may write precipitates are insoluble. So over here precipitates are insoluble in case of aluminium. But if instead of aluminium over here if zinc will be, so zinc ions are present, so that observation will totally be changed and it will be converted into this form like precipitate dissolved to produce clear solution. Lastly, we have iodide ions contain in L. Now iodide is an anion, and for anion you had already learned the test for iodide ion, which was first add dilute nitric acid, then add aqueous lead to nitrate solution. When we are adding aqueous lead to nitrate solution, so our observation will be, before to write the observation for this, I am asking from you what is the purpose of adding dilute nitric acid over here to test for iodide ion. The purpose of addition of dilute nitric acid before the addition of aqueous lead to nitrate is to neutralize any of the carbonate if present in this solution. If carbonates will be present in this solution, then nitric acid will neutralize these carbonate ions, and in order to see that whether the carbonate ions are present in this solution or not, if they will be present, then the bubbles of carbon dioxide gas will produce, and if not, then there will no generation of carbon dioxide bubbles. So what would be the observation that we can see over here? Yellow precipitates of lead to iodide will produce. So what is the conclusion over here? Conclusion, the formula of L is, we have two ions that are present in this compound. One is the aluminium ion and other is the iodide ion. So you can write the formula of aluminium iodide by clearly writing its ions that were or that you had already learned in writing the formula of ionic compounds. One is your aluminium ion, other is your iodide ion, and it has one negative oxidation state. So the number, only the numerical value will shift or in the subscript of opposite ions. So 1 will shift in the subscript of aluminium and 3 will shift in the subscript of iodide ion our resultant formula will be Al(I3). So our resultant formula of aluminium iodide will be Al(I3). Our last statement is referring to the test C2, what change in the observations is seen if zinc ion are present instead of aluminium ions? Here in the CE part 2, as I had already described for you, instead of aluminium, if there will be zinc ion present, then this observation will be changed into this precipitate dissolved to produce clear solution, and that statement we will write over here like precipitates dissolve to produce clear solution. I can solve another one for you, and this is another type of question with colored cations. So L dissolved in water and the solution divided into three parts of the test B, C and D. Over here observation is a colored solution is formed. So if the colored solution is formed, it means that the L is a compound of a transition metal. That's why it is forming a colored solution. Now we are starting with the test. To the first part, aqueous ammonia is added until a change is seen. Now we are not doing it with aqueous sodium hydroxide first, we are doing it with aqueous ammonia first. So to the first part, aqueous ammonia is added until a change is seen. So for Fe2 and Fe3 plus, if we are adding aqueous ammonia, then green precipitates will produce. Green precipitates will produce over here, and if for the second part an excess of aqueous ammonia is added to the mixture from 1, so L contains chromium or Fe2 positive ions. Over here we will write precipitates remain insoluble. Precipitates remain insoluble. But for the second part, if we are doing it with sodium hydroxide, whatever the case is, like if we are doing it with aqueous ammonia at the start or with aqueous sodium hydroxide, as we are adding few drops of it to the sample, so green precipitates will produce. Now with the second part, an excess of aqueous sodium hydroxide is added to the mixture from 1. So for this we will write the green precipitates dissolve to produce to produce green solution. In case of chromium, the precipitates will dissolve, but if instead of chromium we had L contains Fe2 positive ions, then these green precipitates remain insoluble. They will not dissolve in excess of aqueous sodium hydroxide. Lastly, we have the sulphate ion that is present in the solution. So for the sulphate ion, we will do the precipitation test over here. That starts with add dilute nitric acid first. Dilute nitric acid first, then add aqueous barium nitrate solution. We will add the barium nitrate solution over here, and if we are adding the barium nitrate solution over here, it means the precipitates that will produce over here, we will write in our observation that white precipitates of barium sulphate will produce. Barium sulphate will produce white precipitate of barium sulphate will produce. And as we know that it is asked in the previous question, write the formulae of the compound L. So it contains the two ions, one is the chromium ion and other is the sulphate ion. So by shifting the numerical values in the subscript of opposite ions or in the subscript of anions and cations, so we will get chromium sulphate Cr2SO4 thrice. This is the formula of chromium 3 sulphate. The name will be chromium 3 sulphate, because 3 is representing the oxidation state of chromium in this question. Now it can be in the form like in the form of the statements as well. Like the statement of the question is dilute sulfuric acid react with Fe3O4 to form 3 compounds A, B and C. It is the statement of the question like when dilute sulfuric acid reacts with Fe3O4. Fe3O4 is a metal oxide, and as you know that the metal oxides are basic oxides. This is your metal oxide, and metal oxides are basic oxides, but not all the metal oxides are basic oxides, but this is a basic oxide. A, iron 2 sulphate, iron 3 sulphate, C is a colorless liquid. So there are 3 types of things that are forming over here. One is iron 2 sulphate, B is iron 3 sulphate, and fourth one is a colorless liquid. Over here, my main purpose is to describe the test for iron 3 ions. Iron 3 ions test. So the cation test can be described in two forms, whether you can start with the aqueous sodium hydroxide or you can write it with aqueous ammonia as well, because the two reagents are used to test for the cations. Over here I am writing add aqueous sodium hydroxide drop by drop to till excess. Means first we will add sodium hydroxide drop by drop or few drops till excess. So what we will see as an observation, we will write over here or simply if you are not writing add aqueous sodium hydroxide drop by drop till excess, you can only write add aqueous sodium hydroxide. So in observation we can describe like reddish brown precipitate, reddish brown precipitate will produce that remain insoluble in excess of aqueous sodium hydroxide. So we will start with aqueous sodium hydroxide or aqueous ammonia. Like if you are writing with aqueous ammonia, so the same we can write the test. We are adding add aqueous ammonia, we are adding aqueous ammonia as a test, but for observation remains same for both of the reagents. Means first we will write reddish brown precipitate will produce that remain insoluble in excess of aqueous ammonia. So students, this was related to the solution of your sums that comes in your past papers or in your end of year examinations. Hope so all of your misconceptions and concerns have been resolved now. So I hope you will like this video, and see you in your next topic video inshallah. Till then, Allah Hafiz.